What if the future of space exploration hinged not just on, massive rockets and super smart robots, but on something as simple as rice?
But not just any rice.
Exactly, a tiny, like 10-centimeter tall super rice. Because right now, the food astronauts get up there.
Yeah.
Well, let's just say it's not exactly farm to table.
No, it's mostly processed, shelf-stable stuff shipped from Earth. And that presents real limitations for longer missions.
It really does.
You've touched on a really key point there. Long-term survival, true living in space, isn't just about the journey or the habitat. It's about being sustainable, far from Earth's supply chain.
Right.
And fresh food, packed with those vital nutrients, that's a critical missing piece right now. It's fundamental for physical health, yeah, but also, for keeping spirits up on those incredibly long trips.
And that's what we're diving into today, this absolutely fascinating moon rice project. It's this ambitious effort by Italian scientists to, completely reinvent rice for life way beyond Earth. On the moon, maybe Mars.
It's really pushing the boundaries.
Totally. And we'll explore how they're doing it, the genetics, the simulations, all of it, but also why it's so much more than just, astronaut chow. What they're learning could actually mean a lot for us down here, too. Okay, let's get into it.
Sounds good.
So let's paint the picture. An astronaut on the ISS looking down at our beautiful blue planet. What are they actually eating for dinner?
Well, as we said, it's mostly prepackaged. Think foil pouches, maybe some dehydrated items you add water to. It's designed for shelf life and safety, which is crucial, of course.
But not exactly exciting, I bet. I mean, even your favorite meal gets old after a week, right? Imagine months or even years of that.
Exactly. And it goes beyond just boredom, though that's definitely a factor for psychological well-being. The real issue is nutrition. Fresh food is bursting with vitamins, antioxidants, fiber, things that processed foods often lack or have in degraded forms.
And those are crucial for dealing with the stresses of spaceflight.
Absolutely crucial. Extended space travel takes a physical toll. Without that full spectrum of nutrients from fresh produce, you start seeing problems. Muscle wasting, bone density loss, weakened immune systems. It puts the astronauts and the mission itself at risk. So the question becomes, how do we fix that?
Which brings us right back to moon rice. Just how ambitious is this project? Are they thinking this could be like the main food source eventually, or is it more of a supplement?
Oh, it's incredibly ambitious. The goal is genuinely to engineer a rice plant that can thrive during those long missions, maybe even support permanent bases on the moon or Mars someday.
Wow.
Marta Del Bianco, she's a plant biologist with the Italian Space Agency. She put it really well. Living in space is all about recycling resources and living sustainably.
That makes sense.
And what's fascinating is they're basically tackling the same kinds of resource challenges we face on Earth, just, in a much more extreme, isolated setting.
Okay, but plants need space, right? And space is at a premium up there. Current rice varieties, even the dwarf ones, they're still pretty big.
That's a huge hurdle, yeah. Even dwarf rice takes up too much volume and resources for efficient space farming.
So they need something even smaller, like a super dwarf.
Precisely. That's the term they're using. They need a super dwarf rice. But here's the tricky part. It can't just be small. It also has to be productive. You need a good yield.
Right. Otherwise, what's the point?
Exactly. And this is where the clever science comes in. They're working with gibberellin. That's a key plant hormone that controls growth.
Okay.
By manipulating how the plant uses or responds to this hormone, they can significantly reduce its height. But, and this is the paradox, fiddling with gibberellin pathways can sometimes mess with seed germination, or the number of grains produced.
Ah, so it's a balancing act. Small size and good harvest.
A very delicate balancing act, like trying to build a tiny engine that's still really powerful and efficient. It's complex work.
This sounds like a massive undertaking for just one research group. Is it a bigger effort?
Oh, absolutely. You couldn't do this in isolation. It requires collaboration. The Moonrise Project is actually a 4-year program, and it brings together some top Italian institutions.
Like who?
You've got the Italian Space Agency, of course, coordinating things, then the University of Milan, University of Rome Sapienza, and the University of Naples Federico II.
Wow, heavy hitters.
Definitely. And they're only about 9 months into this 4-year plan, but they're already seeing some really promising initial results.
And I guess each university brings its own special sauce to the mix.
That's a good way to put it, yeah.
Right.
Each one has a specific role based on their strengths.
Can you break that down a bit?
Sure. So the University of Milan, they have deep expertise in rice genetics. They're the ones really focused on isolating these mutant varieties that can grow to just 10 centimeters, which is tiny.
Unbelievably small.
Then you have the University of Rome Sapienza. They're looking at the plant's overall architecture, how to genetically tweak it to maximize the efficiency of growth and production within that tiny frame.
Making the most of the small size.
Exactly. And the University of Naples Federico II, well, they have this amazing heritage in space crop research. They bring a lot of practical know-how about actually growing plants in controlled space-like environments. They help sort of integrate all the pieces.
Okay, so they're shrinking the plant, but are they also changing what's inside the rice? I read something about boosting protein.
Yes, that's another crucial part. Think about it. Producing meat in space. Probably not feasible anytime soon. Far too inefficient.
Right, need a lot of resources for animals.
So they need plant-based sources to be as nutritionally dense as possible. What they're doing is trying to increase the ratio of the embryo part of the rice grain compared to the starchy part, the endosperm.
Because the embryo has more protein.
Exactly right. The embryo is where most of the protein and other valuable nutrients are concentrated. So by shifting that balance, they pack more protein punch into each tiny grain. It makes the rice a much more complete food source on its own.
That's incredibly smart, making every gram count.
It has to, in space. Now, how do they test all this for space conditions without actually going to space all the time? Simulating microgravity is key.
How do they even do that on Earth?
It's quite ingenious, actually. They use clinostats, basically, devices that continually rotate the plant.
Rotate it.
Yeah, slowly and constantly. The idea is that gravity pulls on it equally from all directions over time. So the plant effectively doesn't know which way is up or down.
Ah, so it mimics that lack of a constant down direction you get in microgravity.
Precisely. It disorients the plant's gravity sensors. Now, it's not a perfect substitute for true microgravity, of course, but doing experiments in space is incredibly complex and, well, astronomically expensive. So this is the best terrestrial approximation.
Okay, the nutrition side is clearly vital, but I keep thinking about the astronauts. Being cooped up in a metal can for months or years? Does just having living plants around do anything for them mentally?
Oh, absolutely. The psychological benefits are huge and shouldn't be underestimated. Dr. Del Bianco mentioned this too. Watching and guiding plants to grow is good for humans.
Like a connection to life, to Earth.
Exactly. There's a real morale boost from seeing something green and living, from tending to it. Imagine the contrast between another pre-cooked meal squeezed from a pouch versus, harvesting something fresh you helped grow, even if it's small.
Yeah, I can see that making a big difference. A bit of normalcy, maybe.
Bit of normalcy, a connection to nature, a sense of purpose, maybe even a reminder of home. It all contributes to better mental health on those incredibly demanding long-duration missions.
And that's critical, isn't it? Space exploration demands peak performance. You need astronauts who are not just physically healthy, but psychologically resilient.
You absolutely do. They're in isolation, under pressure, performing complex tasks.
Yeah.
They need to be at their best.
Mistakes can be catastrophic?
Exactly. Creating an environment that nourishes them physically and mentally reduces stress, improves focus, and lowers the chance of errors. And like you said, in space, even a small mistake can have dire consequences. The best outcome is wasted resources. The worst, well, it's loss of life. So plants aren't just food, they're part of the life support system, psychologically speaking.
So taking all this amazing space-focused research, what's the takeaway for us back here? Does this moon rice have potential benefits beyond, lunar colonies?
Oh, definitely. It's a classic example of space tech having down-to-earth applications. If you can figure out how to grow a robust, productive crop in the super-controlled, resource-limited environment of a spacecraft or a moon base.
Then you can use that knowledge in challenging environments here.
Precisely. Think about vertical farms in cities where space is tight. Or growing food indoors in places with extreme climates like Arctic or Antarctic research stations or even deserts.
So it could help with food security in difficult places.
It really could. The techniques for maximizing yield in small spaces, managing water and nutrients efficiently, developing crops resistant to stresses, all that knowledge is directly transferable. It could lead to new ways to grow food locally, sustainably, in places where it's currently difficult or impossible. It's not just theoretical. It could have tangible benefits for global food security.
And this isn't just some obscure lab project, right? It was presented at a major biology conference.
That's right. It was presented at the Society for Experimental Biology annual conference in Antwerp, Belgium. That tells you it's significant work being shared with the wider scientific community.
So, wrapping this up then, we've seen how this tiny rice plant engineered for the moon could actually be a huge step for humanity, both out there in space,
And right back here on Earth.
providing not just essential nutrition, but also, maybe just as importantly, that psychological boost for pioneers far from home.
It really highlights something fascinating, doesn't it? How pushing the limits in extreme environments like space forces us to innovate in ways that end up helping everyone. The solutions we develop for survival out there often turn out to be solutions for sustainability right here.
It's an incredible thought. Imagine, maybe years from now, your dinner, whether you're eating it here or on the moon, might owe a little something to the ingenuity behind this 10-centimeter super rice. It really makes you wonder, what other seemingly impossible problems could we solve if we keep reaching for the stars?